Welcome to General Chemistry 2 class. This section is on physical properties of solutions. This lesson is about the units of concentration, particularly mole fraction, molarity, and molality. Let's begin. In this lesson, we will use different ways of expressing concentration of solutions. Percent by mass, mole fraction, molarity, molality, percent by volume, percent by mass, and ppm. Mole fraction, denoted by the Greek letter chi, is number of moles of a component of a solution divided by the total number of moles of all components. In a solution with components A, B, C, and so on, the sum of mole fractions of these components is 1. Example number 1. An aqueous solution was prepared by mixing 0.500 moles sodium bromide and 4.50 moles water. Calculate the mole fractions of sodium bromide and water in the solution. Solution. Get the total amount in moles. Divide the amount in moles by the total amount to get the mole fraction. For sodium bromide, the mole fraction equals 0.100 while the mole fraction of water is 0.900. Example number 2. Given the composition and percent by mass of dry air, calculate the mole fraction of each component. Solution. Let us use 100 grams of air as our basis for calculation. This means for every 100 grams of air, the mass of each gas is the same as its percentage by mass. Now, convert the mass of each gas into moles using its molar mass. Get the sum of the amounts in moles. To get the mole fraction of each gas, divide the amount in moles of each gas by the total amount in moles. The mole fractions of nitrogen, oxygen, argon, and carbon dioxide are 0.7809, 0.2095, 0.0093, and 0.003 respectively. By adding the moles by adding the moles fractions of all gas components, we get a value of 1, which is true for any solutions or mixture. Molarity. Molarity is the number of moles present in 1 liter of a solution. The unit for molarity is molar. Example number 3. What is the molarity of a sodium hydroxide solution if 250.0 milliliters of this solution contains 0.1254 moles sodium hydroxide? Solution. Divide the given number of moles of sodium hydroxide by the volume of the solution. Take note that the volume of the solution must be in liters. The conversion factor is that there are 1000 milliliters in 1 liter. The molarity of the solution is 0.5016 moles per liter or 0.5016 molar. Example number 4. Calculate the mass of sodium hydrogen phosphate needed to make 500.0 milliliters of 0.1407 molar sodium hydrogen phosphate solution. Solution. The molarity of volume of the solution are given and the amount in moles of the solute is missing. Substituting the given values, we get 0.07035 moles of the solute. From the given amount of solute in moles, we can get the mass of solute by simply multiplying the number of moles by its molar mass. You can use your periodic table of elements for the molar mass values. The mass of solute needed to make the solution is 9.987 grams. Yay! Molality. Molality is the number of mole present in 1 kilogram of a solvent. The unit for molality is molal. Example number 5. What is the molality of the hydrochloric acid solution formed by mixing 0.854 moles hydrochloric acid and 750 milliliter water? The density of water is 1.0 gram per milliliter. Solution. Molality is moles hydrochloric acid divided by kilograms water. The given amount of water is in milliliters. Thus, it must be converted to mass using the given density of water 1.0 gram per liter. The mass of water must be in kilograms. Hence, we use the conversion factor 1 kilogram per 1,000 grams. The molality of the solution is 1.14 per mole per kilogram or 1. Ikuan din na. The the molality of the solution is 1.14 mole per kilogram or 1.14 molal. A solution is prepared by mixing 20.0 grams sodium chloride and 80.0 grams water. The resulting solution has a density of 1.145 grams per milliliter. Express the concentration of sodium chloride in mole fraction, molal, and molar. Solution. To get the mole fraction, we need to get the number of moles of sodium chloride and water. To do this, we need to convert each given masses to the number of moles using the corresponding molar mass. Then, we get the sum of the number of moles of sodium chloride and water to get the total moles of this solution. Wow! To get the mole fraction, divide the number of moles of sodium chloride by the total moles. From here, we get a value of 0.0715 as the mole fraction of sodium chloride. To calculate the molality, simply divide the number of moles of sodium chloride by the number of kilograms of water, substituting the moles of sodium chloride and mass of water. With unit conversion from grams to kilograms, we get 4.28 molal. For the molarity, we need to determine the volume of this solution. The solution consists of sodium chloride and water. The sum of their masses gives the mass of solution. To calculate the volume of the solution, divide the mass by the given density of the solution. The volume is The volume is then converted from milliliters to liters, giving a value of 0.08734 liters. Dividing the number of moles of sodium chloride by the volume of solution give us the molarity, which is 3.92 molar. Practice. Express the concentration of 15% m over m aqueous nitric acid whose density is 1.08 gram per milliliter in mole fraction of nitric acid, molal, and molar. Provide calculations to arrive at the given answers. To summarize, the mole fraction of a component of a mixture is the number of moles of the component divided by the total number of moles. Molarity is the number of moles of a solute per liter of solution. Molality is the number of moles of a solute per kilogram of solvent. To learn more about this lesson, kindly visit the references. That's all for this lesson. Thank you.